All right, let's analyze this situation by setting up the hypothesis test. So a golf analyst claims that the standard deviation of an 18-hole scores for a golfer is more than 1.2 strokes. Okay, so I'm going to basically do it and then find the answer, not try and go directly to these answers here. All right, so what did it say? It said the standard deviation, so sigma, is more than 1.2. Sigma more than 1.2. All right, well then right away, I know that that claim there has to have been the alternative because it doesn't have an equals. Sigma greater than 1.2, and that's the claim. We may not need to know what the claim is in this example, but I always like to do it anyway. And sigma, what's the rest? If it's not greater than, it's less than or equal to 1.2. Okay, so that would be here. The standard deviation, that's what they said. The null hypothesis is then this. That's what we had. All right, the alternative, the alternative we said was sigma less than, greater than 1.2. And that's this one here. We already did that. Oh, so now we just said that the alternative was greater than 1.2. So that will easily tell us what type of test we have. All right, remember we always look at the alternative. So being a greater than 1.2, that would be out there. All right, so this is obviously I'm going to write it in and then find the answer. Right-tailed, because the alternative hypothesis contains a greater than. All right, so it's a right-tailed alternative has a greater than. Okay, so now determine the claim stated as null or alternative. How should you interpret a decision? Blah, 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 all that. We'll get there. Scientist claims the mean incubation period for eggs of a species of bird is less than 45 days. Okay, so what it said, first we'll just take what it said and translate it. Mean mu less than 45. Okay, so then I can get my two things here. And actually let me get this a little out of the way. I don't have a lot of room here. All right. Okay, mu less than 45. That would have to be the alternative because it doesn't have the equals. So mu greater than or equal to 45 is up there in the null. All right. And that's the situation that we have here. Okay, so let's see. Does the claim represent the null or the alternative? Since the claim does not contain a statement of equality, it represents the alternative hypothesis. Okay. How should you interpret a decision that rejects the null hypothesis? Okay, claim is in the alternative. That means we're in a support mode. If it rejects the null hypothesis, it brings us to the alternative and supports the claim. That means there is enough evidence to support, so enough or sufficient to support the claim that the mean incubation period of the eggs is less than 45. Okay, how should you interpret a decision that fails to reject the null hypothesis? Again, we're still in a support, But because I wasn't able to get there, I did not have enough evidence to support. So there is, we could say, insufficient, not enough, evidence to support. Okay, so those corresponded. If you like to fill these in, I like to kind of just put the words. Like that. All right, onward. Determine whether the claim below represents null. So same idea. Claim reports, report claims that more than 75% of a households, blah, blah, blah. Okay, P more than 0.75. That's what it's saying. So again, P greater than 0.75 must be the alternative, and the null must be the rest, P less than or equal to 0.75. And again, in this one, that's the claim. So this is going to be very similar to the last one, since it does not contain a statement of equality. It represents the alternative hypothesis. Does not alternative. How should you interpret a decision that rejects the null? I would be saying if it rejects the null, brings me to the claim, there is enough evidence to support the claim. If I rejected it, so is support. If I rejected the null hypothesis, or failed to reject, sorry, I wouldn't get to the claim, so there is not enough evidence to support the claim. Our claim was in the alternative, so we can only do support here. Okay. Your medical research team is investigating the mean cost of a 30-day supply. The company thinks the mean cost is less than 98. You want to support this claim. How would you write the null and alternative? All right. Support the claim. You want to be in support mode. That means the claim has to be the alternative, which means that the claim being the alternative, it cannot have the equals in it. So the cost, mean cost, less than 98, that's exactly what I want in the alternative. And then, because that's where the claim is going to be, and then mu greater than or equal to 98 is in the null. By having my claim in the alternative, I get the support mode. A refrigerator manufacturer claims the mean life is less than 15. You want to perform a hypothesis test. Okay, so in this first case, I want to support the claim. Again, support the claim means that the claim is going to have to be in the alternative. The mean life less than 15, so I'd want it mu less than 15 without the equals. Mu greater than or equal to 15 would then be the null. If I wanted to reject the claim, then the claim would have to be in the null hypothesis. So then the null hypothesis is going to need the equals, so I'd say mu less than or equals 15, because I had to include the less than, but I also want the equals in. And then this is mu greater than 15 as the alternative. A null hypothesis is rejected with a level of significance of 0.05. Is it also rejected with a level of significance of 0.10? Well, this is the alpha. We're going to look a lot more out of this. So I would reject the null hypothesis if, let me put down here, if P is less than or equal to alpha. So if p is less than or equal to 0.05, that's what it's saying, I rejected it. But 0.05 is already less than 0.10, meaning p has to be less than 0.10 as well. If it's less than 0.05, it's less than 0.1. So that would be here. Claim would be rejected. The p-value would be less than 0.1. We only know that here because we already knew it was less than 0.05.